Hey everybody. So today we're going to be doing section 5.2, and this is over the sum and difference formula. So the section's going to be a little shorter because we're only going to be memorizing three things, but they could be a little tricky to memorize. So basically the sum and difference formulas are what happens when you have sine plus or minus a number, or cosine plus or minus a number. All right, so I'm going to go ahead and write the formulas out. And they may seem a little but so let's see. This is sine of A, cosine of B, plus or minus, and then cosine of A, sine of B. And then cosine of A plus or minus B is cosine A, cosine B, minus plus. This means that the sign in the middle flips. And then sine A, sine B. Okay, so let me erase these signs in the middle and do them a different color. So here it's minus plus. All right, so these formulas, they seem a little scary because, yes, they're formulas that you're going to have to know for this next exam, but they're formulas people forget a lot. Usually when they remember that they're needed, you go back to your old textbook and you look it up, or you internet it up real quick. But since we're going to be doing a lot of it in this section, it's worth it to memorize it, at least for now. Okay, so I looked up on the internet different ways to help memorize it, and the best thing I could find was a little jingle, a little song, if you will. And basically, what the song is it just starts with the first one, and they go sine, cosine, cosine, sine, cosine, cosine, sine, 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 cosine, cosine, sine, cosine, cosine, sine, 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 cosine, cosine, sine, cosine, cosine, sine, sine. It's not really a jingle, but it actually does help. Your brain kind of like bounces back and forth when it sings it. And when you start it, it's sine and cosine. And notice that the formulas are sine first and then cosine second, the two formulas that you're memorizing. As far as which one flips and which one doesn't, another mnemonic device to use is that sine has the same sign. All right. Anyway, so the sign will have the same sign. If it's plus, it's going to be plus in the middle. Minus, it's going to be minus in the middle. For cosine, if it's plus or minus, the sign's going to flip. So notice that this guy, it flips based on what it was when it started. All right. So sine, cosine, cosine, sine, cosine, cosine, sine, 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 cosine, cosine, sine, cosine, cosine, sine, 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 cosine, cosine, sine, cosine, cosine, sine, sine. Yay! Anyway, at least for this section, you'll have your notes, and but you'll be referring to this page a lot if you haven't memorized them. So the first question says, find the exact value of sine of pi over 12. Well, that's kind of weird. Notice it doesn't seem like two things are being added, but it turns out that pi over 12 is equal to pi over 3 minus pi over 4. So really what they want us to do is they want us to find sine of pi over 3 minus pi over 4. And so I'm going to get that, and I'm going to move it over to the right a little bit. And before I start, it's something that, again, I always forget it too. Let's create our little table. I have sine and cosine. And here we have 0, pi over 6, pi over 4, pi over 3, pi over 2. So sine starts out with 0, then a half, square root of 2 over 2, square root of 3 over 2, and 1. And cosine just reverses it. All right. So anyway, we're dealing with sine. So sine, cosine, cosine, cosine. So I know that this is going to be sine of cosine of cosine of sine of, because the pattern, sine, then cosine, then cosine, then sine. And since it's sine, it has the same sign, so that's a minus. So this is a minus in the middle. And notice for all the patterns, it's just AB, AB. They wrote the pattern this way so that the order of the terms don't change. So I'm just going to put pi over 3, pi over 4, pi over 3, pi over 4. And we can refer to our table. Sine of pi over 3 is square root of 3 over 2. I'm going to write it a little nicer. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 3 is 1/2. And sine of pi over 4 is square root of 2 over 2. Okay, we do the math. Top times top, bottom times bottom. So square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. 1 times square root of 2 is square root of 2 over 4. And they have a common denominator, so I'm left with square root of 6 minus square root of 2, and then the whole thing divided by 4. So it looks like a scary answer, but on the WebAssign, they do want you to write it like that. They don't want you to do decimal. They want you to write the exact answer. All right. So you're going to see about three of these on the homework. Okay. Next is prove that cosine of x plus 2 pi equals cosine. So remember, cosine is cyclical. So for instance, cosine, let me adjust the settings a bit. No grid. All right. So cosine of x plus, and I'm going to put c here, just some constant. And I'm going to make it go from negative 2 pi to 2 pi. Let's make this, okay, well anyway. So it would help if I had another equation for reference. Cosine of x. The period of cosine is, oh, that doesn't really help if you're colorblind now, does it? Okay, so this is cosine. And let me start at 0. They're the same thing. Now the period, anger. So they're the same thing. So the period of cosine is 2 pi. That means if cosine moves over 2 pi, it's going to be the exact same thing. So if I add 2 pi, we get the same thing. If I subtract 2 pi, we get the same thing. So if you go by intervals of 2 pi, the answer doesn't change. It's still the exact same thing. And so we're going to use this theorem to prove that. Prove that cosine of x plus 2 pi equals cosine. So in the formula, remember it's sine, cosine, cosine, sine, cosine, cosine, sine, sine. So it's going to be cosine, cosine, sine, sine. Okay? And now since we're dealing with cosine, the sign flips. So this is a plus. In the middle, it's going to be a minus. So I end up with cosine of x times cosine of 2 pi, and then sine of x times sine of 2 pi. Cosine of x is just cosine of x. Cosine of 2 pi. Okay, remember cosine, it's a full rotation. And so cosine of 2 pi is the same as cosine of 0. So this is just 1. And then I have sine of x. And then sine of 2 pi is the same as sine of 0, which is just 0. Okay, 0 times anything kills that entire term. And we're left with just cosine. Yay, math works. Okay, let's go to number 3. Write sine of 7x cosine of 3x minus cosine of 7x sine of 3x as a single trigonometric function. So the pattern, it's sine, cosine, cosine, sine. So this means this has to be a sine. All right. Now, when you're dealing with sines, sines have the same sign. So this is a minus, so this is going to be a minus. And then here's your A and your B. So it's going to be 7x and 3x. So this is just kind of piecing it together. 7x minus 3x is 4x, and so you're left with just sine of 4x. Yay! And so again, I can show you on Desmos. So I have sine of 4x. Okay. And then it was sine of 7x cosine of 3x minus cosine of 7x sine of 3x. Oh, that looked cool. Woo. Here you go. You have the exact same function. All right. So on the next page, I have problems for you to do. They're very similar to these 3. Okay, I actually put 4 of them, but work on those, and I'm going to post another video to Canvas that kind of shows how to do it. Not kind of, but it shows you how to do it. But I want you to practice by yourself. All right? So now let's do this example. If sine of A is 3/5 with A in quadrant 1, and cosine of B is negative 5/13 with B in quadrant 3, find sine of A plus B, cosine of A plus B, and tangent of A plus B. And then after you do that, find the quadrant that A plus B terminates in. So this is a pretty big question. You're probably going to see this as one of the questions on the test. But anyway, so if I have sine of A equals 3/5, what I learned from chapter 4 is that I can get this and I can make a triangle out of it. And this is in quadrant 1. So if I make a triangle out of it, my triangle is going to look like this. And sine is adjacent. I'm sorry, it's opposite over hypotenuse. So the opposite is 3, 5. And notice this is a 3, 4, 5 triangle. So I can put 4. Now if you wanted to solve it on your own, you would have said, all right, 3 squared plus something squared, I'm going to call it A, equals 5 squared. 9 plus A squared equals 25. Subtract the 9. And then square root, and that gives you 4, which is that number right there. Okay? But 3, 4, 5 triangles, they happen a lot, and usually in textbooks when you're learning about something, because they don't want to over convolute you with math that's too complicated. But anyway, so we got that. And so with that, I can figure out some stuff. Namely, I can figure out, I know that sine of A is 3/5. And I know that cosine of A is equal to 4/5. Remember that this would be the adjacent over hypotenuse. Now we can do the same thing with cosine of B. Cosine of B is negative 5/13. This one, though, is in quadrant 3. And quadrant 3, the triangle would be in the 3rd quadrant. So it would look like this. Okay, cosine is adjacent over hypotenuse. The hypotenuse is always positive. So the negative, this will be negative 5 because we're going to the left. and this is 13. And so this triangle is a 5, 12, 13 triangle. So this answer should be negative 12. But again, if you wanted to do the math, you would say negative 5 squared plus a squared equals 13 squared. 25 plus a squared equals 169. A squared is equal to 144. And that gives you that a is equal to 12. Anyway, so the whole purpose of doing that, though, was now that we have the B triangle, I know that sine of B is opposite over hypotenuse, and cosine of B was given to us. All right, so now I have these two things, and with that, I can just use my formula now. Let me get all this to make it a little smaller. Hope that song's not copyrighted. Anyway, so now that we have our stuff, I can now figure out all my formulas. So for sine of a plus b, I'm trying to write small so it'll fit. Okay, it'll be sine A, cosine B, the sign stays the same, cosine A, sine B. And I can already look at them. Sine of A is 3/5. Cosine of B, it's down here, negative 5/13. Cosine of A is 4/5. Sine of B is negative 12/13. So we do the math a little more, and that gives us negative 15. 13 times 5 is 65. We can simplify it, but let's not, because the next term is going to have the same denominator, and that'll let us add denominators. 12 times 4 is negative 48. And negative 15 minus 48 is negative 63 over 65. That's 1. Oh, man. And in typical Gilbert fashion, he's going to shrink it, give himself some space to work. So now we're going to do cosine of a plus b. So sine, cosine, cosine, sine, cosine, cosine. The sign flips for cosine. So it's going to be a minus sine A, sine B. And so doing the math there, cosine of A is 4/5. Cosine of B is negative 5/13. Minus sine of A is 3/5. Sine of B is negative 12/13. And so you get negative 20 over 65. Here, notice we have a double negative going on. And so that's going to be plus 12 times 3 is 36, 65. Add them up, and you get 16 over 65. Yay! So that's that one. And now, how do we find tangent? I know if you look at the bottom of the page, there's eventually going to be a formula for it. But for now, to find tangent, let's just do what we always do. If you have cosine and sine, you can easily figure out tangent. So tangent of a plus b is just sine of a plus b over cosine of a plus b. Sine of a plus b is negative 63 over 65. Cosine of a plus b is 16 over 65. The 65s cancel out. If you want, you can use your calculator. Just be sure to put the denominator in parentheses. And then you end up with negative 63 over 16. So there's sine, cosine, and tangent. But really, I could have figured out any of the terms I wanted to. I could have found secant by just doing 1 over cosine. I could have found cosecant just by doing 1 over sine. So really, you can. These are sine, cosine, and tangent, but you can really find all 6 if you wanted to. All right. So now the last question is, what quadrant is it in? So let's go back to these two. And notice that sine, let me put a little plus thing here. That's terrible. Okay, so we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Notice that this value is positive, or negative. Let me try to shimmy it in here. And so the question is, where do we have a negative sign? Well, sine is negative in quadrant 3 and quadrant 4. Okay? Now here, notice that cosine is positive. Positive cosine. Cosine is positive in quadrants 1 and quadrant 4. So where they overlap would be quadrant 4. So to answer the final question, that a plus b, I'll write it up here, must be in quadrant 4. All right, so this is the big boy question for this section. There's just a lot of little math involved, but if you make your triangles, you make the triangle so you can figure out sine and cosine of each letter. Once you have the sine and cosine of each letter, you can just use the formulas. Okay. That being said, when we did tangent, we just did sine over cosine. But to avoid us having to actually figure out sine and cosine just to find tangent, it gets annoying too. So it would help if we had a formula for tangent. So the formula, this is again plus or minus, is tangent A plus or minus, and then tangent B. And then we have 1, the signs are opposite, and then tangent A, tangent B. I don't have a mnemonic device for this. The guy in the video was just saying 10 plus 10, 1 minus 10, 10. And I was like, that's not a rhyme or pattern. But anyway, so this is the formula. And so notice this is the same information from above for question 9. Sine of A is 3/5, cosine of B is negative 5/13. So that means that all of these guys still apply. I didn't want to redo an entire problem. So I'm going to get these and I'm going to copy paste. Actually, if we're using the formula, yeah, nope, I don't need that. What I'm going to copy paste, sorry, is the triangles. Copy paste and triangles. Quicker than doing it over again. Okay, so since the information is the same, we have the same 2 triangles as before. And again, with the triangles, I can easily figure out the tangent. This is for A, and this is for B. So tangent of A is opposite over adjacent. Sorry. So 3/4. Tangent of B is opposite over adjacent, so negative 12/13. And so if you draw your triangle properly in the right quadrant, then you'll be sure to have your positive and negatives correct. But anyway, So now that I have tangent A and B, I just use the formula. So the formula says tangent of A plus tangent of B over 1 minus, tangent of A, tangent of B. So we have 3/4 plus negative 12/13, and then 1 minus tangent of A is 3/4, tangent of B is negative 12/13. And so since they let you use your calculator, you can go ahead and do it. It's just busy work from there to simplify that. And so you could say 3/4 minus 12/13. I don't like typing a whole thing like that in. I just split it up. So let me math 1 that. Negative 5 over negative 9 over 52. Did I do it right? Wait, hold on. I think I did something wrong. Let me pause for a bit while I figure something out. See, I wish we were in a regular lecture where you could call me out and be like, Gilbert, you did something really silly. And I'd be like, I did? And you'd be like, yeah. And then life would be good. So you were probably screaming at me while I was doing this. I'm sorry. Tangent is opposite over adjacent. So negative 12 over negative 5, which is just 12/5. I'm sorry. So that changes. I was like, this isn't looking like my notes are. What's going on? So 3/4 plus 12/5. 12/5. So we go to our calculator. Here we go. Plus 12/5. And then you can math 1 that. 63 over 20. Okay. So, and another reason is for showing your work properly, usually even though you have a calculator, you pretend like you were doing it by hand, and so you do it in little steps, and it shows the person reading it what you're doing. So anyway, I have 1 minus 3/4. Notice I put that in parentheses. 12/5. And then that's negative 4/5, but just for funsies. Okay, now each of these isn't really in parentheses. And so your final answer, 63 over 20, says Gilbert as he doesn't do it. 63 over 20 divided by parentheses negative 4/5. And then you can do math 1. And notice you get the exact same answer that we got before. Probably would have been quicker if I just did it by hand. Anyway, so that's the formula. Good stuff. So on the next page, what I want you to do again is do it yourself. Do number 10, number 11, number 12. So 10 and 11 are 10 and 10's just like we did. 11 and 12 are a little different, but hopefully if you're using your formulas correctly, they should be doable. They're not that bad. Excuse me. So the very last thing I want to do is some more proofs, because we can never have too many proofs. Okay, so remember, for proofs, you have to pick a side. And it says, prove that this expression equals 0. Well, I mean, I can't pick 0 as my side because that's nothing. You go with this. Usually you go with the side that has more stuff in it. So I have cosine of x plus 3 pi over 2 plus cosine of x minus 3 pi over 2. So for here, let me go ahead and write it out. Since it's so long, I'm probably going to go sideways. first, just to use up the whole page, and then I'll go down. I'm going to go sideways so I can clear this guy, and then I can go down and I won't have to be worried about my text running into what's down here. Okay, so this is cosine. So the formulas for cosine is cosine, cosine, sine, sine. So this is going to be pretty big. Let me try to color code it. So the first one is cosine, cosine, sine, sine. So cosine of x, cosine of 3 pi over 2. For cosine, the signs flip. So this is minus, and then sine of x, sine of 3 pi over 2. And that ends the first one that I put in the blue brackets. We're adding them up, so there's a plus sign. And then we work on the other one, which I'm using the purple brackets. And so, again, Gilbert doesn't give himself enough room. It's a running theme in this section. All right, so cosine again. So it's cosine, cosine, sine, sine. So cosine of x, cosine of 3 pi over 2. And then the sign flips, so that's plus. And then sine of x, sine of 3 pi over 2. And that ends the purple one. Okay, so first let's figure out what cosine and sine of 3 pi over 2 is. 3 pi over 2 is 270 degrees. And really that's just the point here. And the x and y value for that point, x is 0, y is -1. So this is going to be the cosine, and this is going to be the sine. So we end up with cosine x, cosine, that's 0, minus sine x. Sine, it's the y value, -1, plus, and again, that's what I put here, cosine x, cosine, again, is 0, plus sine of x, and then the sine is -1. All right, so cosine 0 times anything, that kills that term. 0 times anything, that kills that term. And so you're left with double negative. So I have sine of x. Here, it's plus in the middle, and then minus sine x. And it ends up with 0 as your final answer. Okay, so this one was really just chugging it out. There wasn't really any manipulation you had to do. You just had to write it all out and everything worked. Everything automatically fixed itself. So let's do this next one. Prove that sine of a minus b over cosine a cosine b is the same as tangent a minus tangent b. So I'm going to work with the more complicated side first. So sine of a minus b, cosine of a, cosine of b. So really the only thing I have is my formula. So the formula for sine is sine, cosine, cosine, sine. So sine of a, cosine of b, the sine stays the same, cosine of a, sine of b, and then the whole thing divided by cosine a, cosine b. Now when you're dividing, you divide each one. It's illegal to pick and choose what you want to divide by. Okay, you have to divide the entire thing. So there's two terms here. And then minus cosine A sine B, cosine A cosine B. So looking at this, the cosine B's in the first term cancel out, whereas the cosine A's in the second term cancel out. And you're left with sine A over cosine A minus sine B over cosine B. And that's the definition for tangent. So that gives you your final answer. Tangent of A minus tangent of B. So this was another one where they just want you to just use the formula and chug it out. All right. So this next formula, I was looking at it, and I had more success with this one by actually working on the easier side. Because I tried working it both ways, and for me, the one that made more sense was this one. So this is one of the few cases where if you hitting your head against a wall, sometimes just try the other side and see if it works. But I don't want to waste your time by, making it not work. So I'm going to start with secant A plus B. Okay, by definition, secant is 1 over cosine of A plus B. Okay, now again, by definition, you go down. Cosine is cosine, cosine, sine, sine. So cosine A, cosine B. For cosine, it flips. Sine A, sine B. And it kind of looks like we don't have anything. But like we learned in 5.1, if you see subtraction, try multiplying by the conjugate and see what that gets you. So the conjugate is the same thing with the opposite sign. So I'm going to try to multiply by cosine A, cosine B plus sine A, sine B. Cosine, and it has to be the same thing on the top and the bottom, because anything over itself is 1. Over sine A, sine B. All right. So I know it looks nasty, but remember, just in math in general, if you have, they used A and B, so I don't want you to think it's this A and B. So I'll use P and Q. So if you have P squared, or sorry, P plus Q, P minus Q, if you were to distribute, you would get P squared plus PQ minus PQ minus Q squared. And so these things cancel. And so usually when you see the same thing, just the signs in the middle are different, something minus something, something plus something, people don't actually FOIL the whole thing out. They recognize that pattern, and they just write the answer as the first thing squared minus the last thing squared. So on the top, on the bottom, I have cosine squared A, cosine squared B, minus sine squared A, sine squared B. Now, we're kind of where we want to be. Notice that this is where you have to look at your answer. Cosine of A minus B, well, I already have the formula for that right here. So my numerator checks out, meaning that I don't want to mess with it. Leave it alone. But notice the bottom, it doesn't really make sense. Now the things I want to keep though, basically the things you don't want to mess with, are the cosine squared A, and sine squared B. So sine squared B. I do not want to mess with those terms, which means the terms I'm going to change are going to be these guys. And so the easiest term that I have is to turn cosine squareds into sine squareds, and vice versa. So I'm going to kind of hop all the way over here as I do this. The top changes to cosine A minus B, which is what we wanted. Here, though, I have cosine squared A. I can change cosine squared B, the one that I don't want, into 1 minus sine squared. And then minus sine squared A. Again, sine squared B I can change into 1 minus cosine squared. And on the top, I'm going to try to center it. But when you FOIL and, not FOIL, but when you distribute and work everything out, everything cancels out and life is good. So, so on the top, I have what I want. On the bottom, if I distribute these guys, remember that's a minus, we have cosine squared A minus cosine squared A sine squared B minus sine squared A, and then double negative, minus and a minus, plus sine squared A cosine squared B. And these terms kill each other. And now with those two terms gone, I have my final answer. Okay, I'm going to try working it out from the other side again. I'm thinking maybe I just hit a mental block, but I worked it out with the easier side and ended up getting the answer. Now I'm going to arrange it to make it look like I didn't run out of room. Gilbert's cheating. Shh. You saw nothing. Not me. Look how nice and neat that is. It's like you meant it to be that way. Okay. So it's hard to determine space when I'm zoomed in so much. But notice the effort that I'm taking into making my proof look nice and pretty. Guess what Gilbert wants to see when you turn in your work and he grades it? I want to see the same kind of care taken, that everything kind of flows. Cosine A minus B. And then on the bottom, cosine squared A minus sine squared sine squared A. Sine squared A or sine squared B? Oh, did I copy? I think I copied something done wrong. Hold on. No. I made a little mistake. I need to catch it. Oh, I caught it. I'm just okay. So what I boxed was what I wanted to keep, and my brain turned off a bit. Sorry about that. The term I'm keeping is sine squared b. So sine squared a is the one that changes to 1 minus cosine. There we go. And so now those change. When I distribute, that changes now to sine squared b. But the other term still cancels. Nope, stop it. Sine squared b. And then this becomes cosine squared a sine squared b. And now they actually do cancel. Oh, I'm sorry. So cosine squared a minus sine squared b. Can you imagine if I was like a perfectionist and I'd like to redo the video every time I screwed up? That would be terrible. But anyway, so that's the hardest one here. On the next page, there's some proofs I want you to do. And notice the last one is pretty much exactly the same as the one I did, except instead of secant, it's of a plus b, it's secant of a minus b. All right, so work on those. Again, on the homework, there's going to be problems that you have to actually do in person, not in person, but on paper, and you have to upload that to Canvas so I can grade it. Okay? The homework system temporarily counts it right until I actually grade it. Anyway, have a good day, and remember to try the problems that I skipped, and check them out in the video that I put underneath this link.